a weird little walk down memory lane. Chapter 4. What kind of distributions did chapter 4 talk about? That was the quiz we just took. Say again?
Normal.
No, that was chapter 6.
Oh.
Chapter 4.
Oh.
I thought you said horrible, so I was like, oh shit. All right. Speak your truth.
Was chapter 6 uniform? 4 uniform?
5 is uniform. I love it. We're getting there. Yes. Discrete. Oh, kick ass. All right. So chapter 4 was all about discrete distributions. Those are the easiest freaking ones to figure out what the probabilities of some situation are. Why is that? Well, because in the first part of chapter 4, they tell us exactly the probabilities of each thing. So if I said, what's the probability it's at least 1, you just 30%. You could see, there's no calculations to do. You could just see it, right? You guys semi with me? And this is discrete, because if I say, what's the probability I get 0.739, what's probably I get 0.739? What's probably I get 0?
0.77.
70%, right? So it's probably I get 0.739. Is it possible? What's the only things I could possibly get? 0, 1, 2. So what's the probability I get 0.739?
0.
0 chance, right? What's probably I get a car that has 0.739 doors on it? 0. Okay, I like it. So discrete. And of course, and then of course the binomial situation is also discrete, except now we have a little bit of work to do because it's not as nice and easy as this. But still, this can only be a whole number, right? Because normally I'm talking about picking so many out of a group of something, and I don't want to take half of a dolphin or something. That's horrible. Let's not do that. Or half a person, right? Let's not do that. All right. Then we made the transition into chapter 5 and 6. Chapter 5 was sort of like a little baby step. Chapter 5 was our first taste of continuous. And it should kind of make sense. If this is dealing in 0, 1, 2, and this is dealing in anything is frickin' possible, then we should expect this to be a little harder. The funny thing is, when I have a uniform distribution, is that a difficult problem to work with? No, because why?
It's all the same.
What do you mean? Yeah, it's all the same. But every time I go to answer a probability question, what shape do I end up creating? Rectangle. And then we talked about the fact, I did the dartboard thing. I want you to intuitively understand why probabilities are directly related to and actually equal to the area if I make the area of the whole thing 1. So if the area of the whole dartboard is 1 and the area of the bullseye is like 0.1, then there's a 10% chance you'll just randomly hit the bullseye. I like it, maybe. So uniform starts off nice, that's easy. But then we go to chapter 6 where things get freaky because, I can't get the area of a shape like that easy. Okay. All right, so this is just kind of like a higher level view of what the hell we just did. Every situation, I'm just wondering, what's the probability that something happens, right? And one thing about probabilities humans don't understand is if there's a 95% chance of something happening and it doesn't happen, that's okay. Because there's a 5% chance it won't happen. So we sort of like round up when things get big or small. We're like, there's only a 1% chance, but it happened. No, there was a 1%, it could happen. Okay. Now, let's kind of like get some more details. So, coming back, we had a quiz on this today, so we had time to answer questions on that. Uniform, really straightforward. I told you the mean and standard deviation. I know I put it on the practice test. We'll talk about it, but I won't put it on the test. Let's focus on 6 and 7. So chapter 6, what's going to help us is calculating z-scores. Let me see if this makes sense. If my z-score is 0, what does that mean?
Your 0 standard deviations away from the mean.
So I'm at the mean.
Yeah.
I love it. What percentage of the picture is below me? If I have a normal curve. Yeah, because the mean cuts it in half. Cool? So shouldn't it make sense then, if I'm at like 0.3, the area below that should be more than 50%. So when you look at the z-score chart, as you move higher and higher positive z-scores, that just means we're moving further and further up. And because the shape is so well regulated, I can translate the number of steps up I am into the amount of area I've left below me. That's why the chart makes sense that it freaking exists. And that's why we're so damn happy it exists, because I don't know how to calculate the area of this shape. I do, but in general, we can't do that normal geometry, right? Okay, I like it. You guys are like, good for you, man. Okay. All right. So let's actually do a problem then. So if I give you, if I say the mean is 12 and the standard deviation is 2.91, and I tell you it's normally distributed, can you guys just take a second and draw the picture for me? Just draw the picture. So of course it's normal, so you got your little hump dude, right? Right in the middle goes 12, and that's really all you gotta do. You don't have to do standard deviation. Okay, so drawing that picture is pretty easy. So it's just like drawing the big ass rectangle for some given uniform distribution. I want to give myself a visual anchor to work with it. With uniform, it kicks ass, because when we do a little slice of it, it's just a rectangle. I don't need any help. I don't need calculus. Get out of here. It's a rectangle. It's great. It's fantastic. So now if I ask you, what's the probability that I pick something that is less than, what do you got, Jeff? Less than 9?
Be like one standard deviation away, so.
Is it 1?
A little over 1.
Ah, so we got to be very precise.
So
So where is 9?
it's the left fold.
Yeah. And what's the area that I want to find? Where is it? Can you shade it in?
To the left of 9.
Yeah, the beautiful thing about inequalities is they point in the direction you're supposed to shade when the variable's over here. So I want this area. So already I know that my answer is going to be less than
9.
half, less than 50%, because it's a little less than what the means got below it. Okay. And again, you don't have to, I think I said you don't even have to draw the picture really, right? But my God, the people that are going to make the silliest mistakes are the people that don't draw the picture. Okay. So already I know the answer has to be less than 0.5. So if I get an answer of 0.7, I'm like, what the shit did I do? Okay.
So we need the standard deviation of x bar. So,
Whoa, did I take a sample?
oh no. So standard deviation.
So this standard deviation works for, does this work for individuals or groups?
Groups.
No, individuals, right. The standard deviation they give us, so how did we calculate standard deviation back in chapter 2? Didn't we have a list of each of the individual data points, right? And then we had to do the x minus x bar and square it, all that kind of crap. So the spread that we calculated was based on individual data values. Thank the gods we don't have to make a new table, because I showed you that example, that crazy ass example with the numbers in a hat. It was colorful because it had blue and yellow, right? And we actually created the table, but we talked about the fact that if I had 70 numbers in a hat and I picked 7 of them, that table would be stupid big. It would cover the entire back wall of the table would. So my God, please give us a shortcut, and thank God we do. We have that standard deviation formula, sigma over square root of n. We're not there yet. Well, how do I know I'm not there yet? 2 things. Have I taken a sample? No. Am I asking about the sample mean? No. I really want this to make sense, so I went through the complete derivation. We went to alternate universe Florida. We're fine. We came back. We talked about all that shit. But all it boils down to is If I take a sample and I ask about the sample mean, I just have to calculate the standard deviation that works for those kind of size groups. So here I'm picking one thing, and I want to know its probability is less than 9. So what's the next step for me?
Figuring out the z-score.
Z-score, because I want to use the Z-score chart because I know it'll work because it's normal. So Z-score chart is just sitting there, all the answers to any question that comes from a normal curve. It's just got all the answers, and all I got to do to use it is to convert my stuff into Z-scores.
Then you 9 is 3 away from the mean, and if the standard deviation is 2.91, that'll be 1.01 standard deviations away.
Negative 1.01?
Or 90, it's 97%, 1.03, yes, I did do it on the calculator.
Okay, so everybody double check. So we do 9 minus 12, 3 divided by 2.91, negative 1.03?
Yeah, because it's 2.91 is 97% of 3, so 0.03, yeah, 3%.
Okay, let's all double check. Why does it make sense it's negative?
Because it's left.
Yeah, it's below the mean, 11. Cool. I like it. So a lot of what I kind of sprinkle in like I just did, why does it make sense it's negative? These aren't things you necessarily have to kind of like have in your head, but it's just little checks and balances. You know you're on the right track. You got a negative z-score. You know you're on the right track. So is that how it came out? Negative 1.03? Okay, so now what do I do? To get the answer. Now I can get the answer. Yeah, look on the chart. Look on the answers. The minute I know it's normal and have a z-score, the z-score chart's just like I got all the answers. Where did I put all my z-score charts? There. So when you look at negative 1.03, what do you guys get? Yeah, 15. It's neat. When do I know to do 1 minus what I get? Why do I not do 1 minus that? When would I do 1 minus that? I could do one change. If I make one change to my question, I would have to do 1 minus this.
You're looking for the.
If I want greater than. So, bless you. If the question is below, that's awesome because the chart tells me areas below. If the question is greater than, I'm like, shit, the chart doesn't tell me areas above. I got to adjust the answer when I get it. So don't overdo it. I always get somebody to do 1 minus in this case. I think that they're just covering their ass and going, I'll be right eventually. But you don't have to do 1 minus if the answer you look up is exactly what the problem wants you to look up. That's why I want you, if you shade this in, you kind of have that visual clue. Did I get the answer yet? Yeah, we did. We got exact man. It's unfortunate it looks like ISIS, but it's okay. Now, what if I did a part B to this? And I said, now we take a sample of 14 things. What's the probability that I get a sample mean of greater than, what do you got, Jeff? Greater than 13, sure. My work will be exactly the same because this is fundamentally the same kind of question this is. What's the only difference? I've taken a sample, I'm asking about the sample mean. So I really want this just to make sense. This was constructed from individuals. It tells me how spread out individuals. So if I pick one thing, I can actually find it in a picture of individuals. This thing, I'm taking a freaking group. I need to compare it to all the other groups. Is it going to have the same standard deviation as this? No. So what's going to happen to it? Yeah, divide by the square root of n. As n gets bigger, the less likely it should be to get far away from the mean. So the whole thing just sort of like regresses to the mean. It just comes into the center. So whatever the hell that is, 2.91 divided by the square root of 14. 0.7, I don't know which way to go from there. 751? Did I go the right way? 0.751. .74 something.
What's the square root on top of the square root of it? What is
Sorry?
that?
Square root's on the 14, right?
There was one, to the left of that where you have it, before you wrote it, 2.91, you have like a square root over square root of n. I think that's what she was.
Oh, no, so this is my sigma. This is what my sigma looks like when I get all excited. It gets kind of like, sorry.
Sorry.
No, you're good, you're good. Trust me, I feel for you guys. I did have once a teacher that would teach like this, and then you take so all of us were in the front row, just kind of like, and he would do this, and then he take this, and then he would do this. I'm like, no. Hey, sorry. Me, you just can't read what I'm writing. That's all. So, what do you guys get when you do? What did you get? Did I get close to it?
I got .778.
778.
Yeah.
Okay. All right. I'm okay with that. I'm trying to do that in my head. Not the greatest, easiest thing. So, how much work have we done yet on Part B? Have we done a lot of work on Part B? We've done nothing. We just divided that by square root of 14. Now, I do all the same shit here. Exactly the same work, except right there, I'm just going to use the correct spread. I'm just going to use the new standard deviation. So, still the same picture. It'll be a little skinnier, but you don't have to worry about that. 12, 13, I want greater than 13, so now I make a z-score. 13 minus 12 divided by that thing. Come with 7. 10, 8, 5, 4, 1.25, so 1.3. Probably 1.38. I don't know, just making the shit up.
There, close, 1.28.
1.28? Damn it, I went the wrong way. 28?
2.9.
2.9? 2.9. Okay. Right, and now what do you do? The minute you make a z-score, what can I do?
Look at the chart.
You look at the chart. Now, real quick, is anybody concerned? Was my sample, what does my sample have to be bigger than to say that it's approximately normal?
31.
30. It's got to be bigger than 30. This is not bigger than 30, correct? But why am I still able to do it? Because
It's the right.
it was already normal, right? So it's only if I don't know what the original looks like, then I need to have a sample size greater than 30. What was their sample size here? How many people did I pick? 1. We didn't care because it's already normal. So if it's already normal, a sample can be however big it wants to be because it's already normal. So when I look up 1.29, I'm not going to get the answer, right? But what do you get when you look up 1.29?
0.9015.
9015? And so the actual answer is
0.0985.
there. So just about 10% chance. Again, why does it make sense that it's a relatively low chance? Because we took a sample. The sample mean should be close to the actual mean. So now to be further than 13, it's going to be a relatively low chance. Okay, maybe. Okay, so. I've got a handout. It's crazy. You will need your calculators. You will need your z-score charts. Let me see. I'm going to try to put you guys in groups. We'll see. One side of it says normal distribution practice. I want us to start there. This side is chapter 6. I'm not taking samples. I'm not doing any of that. It's just straight up chapter 6. Makes a z-score. Look it up. The other side's going to be where I will take a sample sometimes.
Normal distribution practice.
So again, normal distribution practice. Yeah, that side. let's do it this way. I'll just group people who are close to each other. Let me see. Can you three work together? You with me? Fantastic. You three here. Okay, I like it. And then we'll just go, what about you three here, you three back there, right? You guys with me? Okay, you three here, and then you three back here. Okay. It would be great if you would like move into position so you can talk to each other. Help each other out. If your whole group has no idea, call me over. All right, guys. I'm going to kind of catch up to you a little bit. I can't. It's my job. So, these kind of problems, I'm going to give you a mean. I'm going to give you a standard deviation. I'm going to ask you a question about a specific data point, right? So, again, we talk about concepts. We talk about deriving formulas. But when I give you a question, the hardest thing in mathematics is, when do I do which thing, right? That's the hardest thing. These have a look to them. I give you a mean. I give you a standard deviation. I tell you it's normal, or n is greater than 30, meaning you can draw the bell shape. And then I ask you what's probability is less than whatever. Okay, that's an automatic normal distribution problem. That's an automatic z-score problem. So when I draw this picture, I know it's normal. What goes right in the middle? 718.3. So every one of these problems, I'm going to have a 718.3 in the middle. I'm curious about 770, and I want to know the area less than that. So this area. So right off the bat, I know it's going to be more than half. It's going to be more than 50%. 11. I know it's normal. If I have a z-score, I can look up the answer in this chart. So of course it makes sense. The next step is I'm going to make a z-score. Why am I not changing the standard deviation? I don't even know if I want to bring that up right now, but why does this problem not require me to change the standard deviation with the sigma over square root of n thing? I'm not taking a sample. I'm not asking a question about the sample mean. Right? I'm taking one person. So the z-score, x minus the mean over the standard deviation, so it's going to be our data point that we're curious about, minus the mean, divided by the spread. And what'd you guys get for that?
0.231.
231, so 0.23? Why do I round z-scores to 2 decimal places? Because this chart only goes two decimal places. Whatever, Jeff. All right. Sorry. So if I look up 0.23, you get 5910, and thankfully that's pretty much exactly the area. Let me put it over here, 5910. So about a 59.1% chance somebody on an exposure level less than that. By the way, do you guys know who is up here besides like physicists working with highly radioactive stuff? Do you guys know that if you go on a plane, your radiation exposure goes up quite a bit? So, pilots and flight attendants and all that, they have to be careful about the amount of flying they do because their radiation exposure has gone way up. You don't have as much atmosphere to protect you. So if you do a lot of flight, a lot of getting on planes, you're getting exposed to more radiation than normal.
So you're telling me since I was 6, I've been getting that much radiation exposure?
Not like a crazy amount, but over time it could accumulate. It's sort of like when you go to get an X-ray, don't they put a lead vest on you? If you only get one X-ray in like 10 years, you didn't really even need that. But if you get a lot of X-rays, you definitely want that protection, right? It's nowhere near an X-ray level of radiation on a plane. Don't freak out. Okay.
Oh, I'm not.
Good job, Jeff. You just freaked the hell out of it. Part B is exactly the same problem, except now, so I still got 718.3. Now I got 860. I want the area above that. I know it's going to be probably relatively small. I make a z-score just like before. My data point minus the mean divided by the spread. By the way, I know I say this a lot. I really want this to make sense. I know the data point that we're interested in. I want to know greater than 860. We know the standard deviation is like 200 something. So this is not terribly far away from there. You guys understand what I'm saying? But still, it's definitely up here. The further up I go, the less stuff should be out here. Does that make sense? If I'm here, isn't there more stuff above it than I am here? So as I move up, there's less area above me. So if I just knew how relatively far from the mean I am, I should have a way to figure out what that area is. And that's exactly, a z-score just tells me how relatively far away from the mean am I. So what do we get for this? Let's see. Did anybody do that yet?
Z-score got 0.63.
0.63. Now, a huge mistake I see people make. What does that mean, the thing I just calculated? What exactly does that mean? This number here.
0.63 standard deviation.
Yeah, 0.63 standard deviations above the mean. I'll get somebody make this 63% and then circle it, right? This is not a percentage. This is just where I am. So it kind of makes sense. If the standard deviation is 200 something, one step up would be 900 something, yeah? So it makes sense that we're not even a full step above the mean. So when you look up 0.63, what area do you get?
0.7357.
7357? And because I drew my picture and being nice to myself, I know I haven't got the answer yet. So to get the answer, I need the area above this. So what would I do? 1 minus that. 2643? Okay, so about 26.5% chance somebody gets more than 860 millirems. Crazy. I think that's per year. I can't remember. That would make sense. All right, I like it. So all of us experience radiation at all times. Just if you're in a plane, you experience a little more. Okay. And then part C is sort of like it's almost like a busy work problem because now you have to do 2 z-scores, you have to look up 2 areas, but it's the same exact process. I take the raw score, I make it a z-score, I look up the area. I just have to do it twice now. So my mean is still the same. I went from 60 up to 400. I want this area in there. So we've got to make a z-score out of 400. And then they got to make a z-score out of 60. I always have Mulan in my head when I do that. Make a man out of you, make a z-score out of this. Thank you, somebody got it. Okay. He's like, that was almost funny, John. All right. It's just for me. So if I do 400 minus 718.3 divided by 223.56. Again, what I just did was to figure out how relatively far away my data point is. That's what z-scores do. And of course, how far away from the mean I am is directly related to the amount of area that's below me. If I'm further down from the mean, I have less area below me. That's what this chart's job is to do. It's just give us what that area is. So we got, what is that? We went down 1.42 steps. What'd you guys get for 60 z-score? Anybody do that? 2.94. Let me see what I get. Look at me go. 2.94. I love it. Kick ass. Now, I want to say there are other ways to do it that make mathematical and geometrical sense. To me, the most direct way to do this is to look up the z-score for 400, to look up the z-score for 60, and then subtract those areas. I never subtract or add z-scores because z-scores tell me where I am. If I had to subtract them, I'm teleported somewhere else. Which would be cool if I just had to add 2 numbers and teleport. That'd be awesome, but it doesn't work. So what do you get when you look up negative 142? What's that area? Yeah, 0078. Is that right?
0778.
0. If I could just read 0778. And what about for negative 2.94?
0.0016.
So I want to take 0.0778 minus 0.0016. Okay, there we go. If I do that, I get 0.0762. Okay, I like it. And again, just so you know, chapter 6 is really, there are interpretations. I can see what this means physically, but this really is just the fundamentals of just using z-scores to get areas. Yeah.
So this is the area between 64 and
Do you have one of these?
I do.
You do? Okay. You need one for right
I
now?
need that one, but I have one.
Gotcha.
But I'm just making sure that I'm understanding this. So this
Yeah.
1.62 is
So-
the area between.
Between those two,
64 and
exactly. Kick ass. And just like we talked about before, area is the same thing as percentage, is the same thing as probability. So the probability that somebody has between this many millirems of exposure is about 7.62%. Okay. I like it. So if we want to see what it takes to get into the top 2%, which is not a contest I want to win. Top 2% is there. So what's this? And why do I care about that side? Because I need to use the chart to get a z-score, and the chart only understands areas that are below. So what is this area? 98. Now, it is desperately evil, which is a neat phrase, that this looks like a freaking z-score. We're the humans. We have to know it's not a freaking z-score. It's an area. That's why I put it up here for myself. So do not look 0.98. That doesn't make any sense. I know the area is 98%. I need to figure out what that z-score is. How far do I have to go up until I leave 98% below me? So I have to find it in here. This is where the areas are. This is where the probabilities are. So the closer I get to 0.98, 2.05, I love it. If you want to use 2.055, that's fine if you want to split the difference. Otherwise, you just get the closest you can. 2.05. So now I know this z-scores. So what does that mean? What's a z-score of 2.05 mean?
It's 2.05 standard deviations away from the mean.
Beautiful. It's 2.05 standard deviations above the mean. So the formula, we don't need you. Because I mean, I'm 2.05 standard deviations, 2.05 of these, above the mean. That's just using what a z-score tells me. It happens to also be the formula. Because, of course, the formula catches ideas. That's all formulas do. Formulas catch ideas. And we saw that really explicitly in probability. There were so many times we did not want to use the probability formula because it was more easy to just directly apply the idea. So I don't know. What the hell do we get when we do this? 2.05 times this plus 718.3. What do you guys get? 1,177.76.
I think that might be because of 2.055 as the z-score.
Oh, neato. Let's do this one. So an 18.3 plus 2.05 times 223.56. So we get 1176.598. Now this is if you use 2.055. So when I grade a test, I just go with whatever you use. So when you look up a z-score, you can either take the one that's closest, or if it's sort of symmetric on both sides, like really, see how this one was 2 away and this one's 3 away, so it's roughly right in the middle. So 2.055, tiers come down. Do you get more points for doing that? No, I don't give a shit. So it's just whichever thing you want to use, I'm cool with it. Okay, I like it. We're sort of giving up on exact preciseness, and in place of that, I want understanding, which is what's most important in a class. So if I use a calculator or a computer system like Excel or something, I can get the exact right answer. I don't care, because we don't learn anything from that. This many watts, by the way.
Millirems.
So this is how many millirems somebody would need to be exposed to be in the top 2%, which again, we don't want to be there. So this might be like I said, a pilot, flight attendant, somebody who flies like a lot. This could be one of them. Okay. Or an x-ray tech, right? Because they can't fully escape the x-rays. No one can.
Say astronauts, maybe?
Sure, astronaut. Oh, hell yeah.
Yeah.
Shit.
Because they don't even have an
Astronauts are freaking like way up here. You gotta be careful. Okay. Especially out there doing walks and stuff. So P23. What does that mean, P23? 23rd percentile. Where would that be? What would the mean be? What percentile is the mean? 50th. Because it's got 50% below it. So where would the 23rd percentile be?
left of that.
Down here. It's got 0.23 below it. So again, that's an area. I'm giving you an area. If I have a z-score, I can look up the area. If I have an area, I can look up the z-score. So if we look up 0.23, and of course it's going to be a negative z-score. 0.2, Jeff, you can do it, buddy. 0.23. There. That's the closest I get to 0.23. It's negative 0.74. And then what do I do with that? Is that the answer? Negative 0.74 millirems? Like you are giving off radiation. Well, we do actually give off radiation, but what do I do with that?
That's where you subtract it from the mean.
You do the same formula, yeah. So it's the mean plus, well then z-score is negative, so minus 0.74. So from the mean, I go down 0.74 of these. And then just throw that in the old calculator. 84, 50, 568, so like 5. That's a rough 550. I don't know. Yes.
Why did you look on the negative side of it?
Oh. So do you agree with the picture when I drew it to this point? Okay. Is that below the mean or above the mean? So the z-score is going to be negative. Yeah. I love it. That's why the picture's so important. It helps us. What do you guys get for this here?
552.56.
Oh, 552.56, blah, blah, blah. Okay. So if you have this much radiation exposure, I think it's in here, then you would be in the 23rd percentile. Only 23% of people have less than you. Okay, now, it's already 10 to 11. Let's see. Let's do this. Let's do one of these two. I think we'll do the second one. Yeah. And then I'm going to open it up to practice test. We got to make the formula sheet still. We're going to kind of like soldier through. We won't take a break. Just once we kind of open it up, you can take a break if you need to. I'm trying to see if we can get out early, but if we need more time, it's perfectly fine. So read through this real quick. So let's see, 2004. Yes, it's unfortunately very possible. How many of you guys were born in 2004? Okay. I still remember being freaked out that some of my students were born in 1980. That's a while back, obviously. So, yeah. All right. So if you were born in 2004, you had a life expectancy of 80.2 years. Unfortunately, that's gone down. Even before the pandemic, because we had the recession and all that stuff, and then the pandemic and all that stuff. Anyway, so you had a pretty good little, predicted thing going on. If we select a sample of 37 California infants, it sounds really weird, Why is it okay to use the z-score chart to find probabilities?
It's derived from a normal probability, so.
Is it? Did I say it was normal? Yeah. Beautiful. N is 37, greater than 30. Central limit theorem says, okay. Central limit theorem says, soda. All right. You guys with me? So central limit theorem, that's the one that said, if I get above a sample of 30, the sample means will be normal enough. So now I want to know the probability that the sample mean is less than 75 years. So before I do any picture, before I do anything, what's the very first thing I should do? Did we take a sample?
Yes.
Or am I asking about the sample mean?
Yes.
So what's got to change?
Let's go to that.
Standard deviation.
Yeah.
So I know all too well. Summer, it's like I'm just throwing shit at you, just concepts. I desperately want this to make sense. The standard deviation they give me was calculated based on individuals. So if I have a question about picking one person, I use that. It's fantastic. They go to, I have a question about a group of 37, so I've got to construct the spread for groups of 37. That's all that step does. So if I take the old standard deviation, 14.9, divided by the square root of my sample size, I'll get how spread out those groups are. I didn't prove it, but I showed a concrete example of that happening with that handout. Oh, there it is, this guy. I understand some of you guys are like, I didn't know what the shit we did when we did that. You know, I understand that could happen. Just, ask me. Okay. So is everybody with that? So I listen, I am not going to bold and underline things like this on the test. I'm being really nice right here, but what tells you to do this if I took a sample and I'm asking about the sample mean? That's when you do this. So what is 14.9 divided by 2.45? 2.450? Oh, neato. Okay, so that, I like it. 14.9 divided by square root of 37. Yeah, 2.4495. So that would be 2.450. Kick ass. 49.5. Is that closer to 50 or 40? It's closer to 50. So that would be 2.45. Oh, I love it. Because standard deviation, how many places do you have to go out for standard deviation? At least 3 places. So you can go out more if you want to. That kicks ass. Okay. Just don't give me like 18 places. Holy shit. Yeah, 17's fine. No. Now I do all the same stuff. I put the mean in the middle. I put the thing I'm curious about there. Less than that. Now I make a z-score out of this. But now I use the correct spread. That's like negative 2.07. Yes.
Can you just explain what the 2.45 is again?
Oh, all right. So the 14.9 is 14.9 years is the average distance from the average that people get,
The average.
individual people get.
Average from the 80.
Yeah, so 80.2 is the average. On average, people get 14.9 years away from that. Okay, I love it. When we do this, now I know how spread out groups of 37 are. So on average, a group of 37 will only get 2.45 years away. And that,
So the 14.9 is like everybody and
no, yeah, the 14.9 is individuals. How spread out are individuals from the mean?
So
one.
This is how spread out our groups of 37. And again, if I took a group of 37 people, they should be closer to the average. And that's why they get further away less often. That's why the spread gets smaller. If I take a sample, their average should be closer to the actual average. Okay. And now what I get a z-score. Did I get close? What did I can't remember what I said it was. What do you get? Sorry. Well, negative 2.12. Yeah, you only go 2 decimal places because that's all the chart does. I like it. And then I look that up. Yeah. And I can get this area here, right? Okay, look up negative 2.12. And I just get 0.017. There's a lot of... Whee! And that kind of makes sense. If I take a group of 37, what is it? 37 infants, their life expectancy average should be close to the actual average. Okay. All right, so let's do this. Part C and Part D, that would be exactly the same. Part D is a little bit more interesting, so I'm going to do Part D. Part C is just like Part B, just 2 things. You have to calculate this and this, the z-scores, right? So let's look at Part D real quick. The sample mean ages bounding the middle 95%. Right, so like, oh God, Jeff, why? So bounding the middle 95%. Could you guys draw that? The middle 95%. So if I chop it, I want to chop it, so that I catch 95% in the middle. Does that visual make sense? I want the middle 95%. So if I, let's see. I can do it here. If I had a log, right, there's a log, and I want to cut out the middle 95% of the log. Chop, middle 95%. So that's all I'm doing here is that's the middle 95% of the picture.
0, 2, 5 on the left and the right.
Yeah, I was going to say, with the chart's not going to understand the area at all because it only understands areas that are below something. So this one's got a couple steps. I want to know what these z-scores are because then I can convert each of them back into a mean age using that mu plus z sigma formula that we had. So I want to look at the z-scores. Yes?
If it's natural and you want 0.95%, why can't you just do 2 standard deviations?
Oh, I love it because it's not quite 2. That was rounded. So empirical rule, we talked about this real quick, it just rounded to 68.95 because it just made it easier to remember. So it's not exactly 2, but I love that you brought that up. That's beautiful. It's almost 2. So I can't look up 0.95 because it's not an area below a z-score. What area is below that z-score? Yeah, 0.025. Is that cool? If there's 95% in, there's 5% out, so there's 2.5% on that side. If I look up 0.025, I can find that z-score. 0.025. Dude. So what do you get? You almost get 2. You get negative 1.96. Now, can somebody tell me, this is the middle 95%, chop, so what should this one be? Chop, middle 95%. The middle is 0, so that's negative 1.96. This is going to be, you can do it. 1.96, it's symmetric. And then you do this formula for each one of those. Okay. So that's kind of like, I like that problem, and of course I do, because it's actually, just to give you a little clue, it's getting us ready for chapter 8. So let's do this. Does everybody have a practice test? Anybody need a practice test? I have the answer keys for this. So let's do this. Before we open this up, let's create the formula sheet. And then we can do specific problems, any questions you guys have. Yeah.
So it sounds like I failed on the fifth.
Yes. We're all crazy. All right. So the formulas, you can just add these to your test one formula sheet if you want to, or you can have like separate formula sheets for each thing. And then on the final, you just bring them all with you. Right? So this one, this test is going to be chapter 4, 5, 6, and 7. Chapter 4 is where we had the stuff from the quiz today. Right, so that's if I give you an X, P of X table. So that's section 4.1 and 4.2. And then we get binomial stuff. And I don't mind if you do something like this. This is all related to binomial. This is all related to general probability distributions. Just be really careful. Some of you guys did lose some points on your last formula sheet. Right? That's, math teachers were evil, so we do that kind of shit. If you're not sure about something on your formula sheet, just ask me before the test starts. I'll make you a fresh one if it's not good. Basically, you can only have on there what I put up here. It's pretty straightforward. That's chapter 4. Chapter 5, there really isn't any formulas. I'm not going to make you do remember the mean is a plus b over 2 and the standard deviation squared of b minus a squared over 12. Okay, so you have to know they exist. You have to do some homework problems. I have a problem on the practice test like that. I'm not going to put it on the actual test. It's just not used often enough to worry about. But I want you to know they exist. So chapter 5, no formulas for it. You just have to know, draw the big triangle, the rectangle, and then find the areas. And then we hit chapter 6, which is where we have this bad boy here, of course. We have this thing, which is really the same exact formula, just for sample information, right? Then we have the backwards formula. So that's all chapter 6 stuff. And then we have chapter 7, which is what introduces this guy. And if you want to, yeah, sure, why not, Jim? It's all the same formula for Z-scores. They're exactly the same formula forever. They're always our data minus the middle divided by the spread. That's what they all are. So see, all this one says is, if I have a sample I take, I want to use the spread for groups, not the spread for individuals. That's just what that formula says, okay? Does anyone think I've left off any formulas you want? You're all like, that's plenty, man. But is there anything you think I left off? I'm only human. I can certainly forget. Okay.
So the top one is groups and the bottom is
6. So this is for individuals. This is for groups. Yeah. So how do I create this? By doing this. By the way, you all cool with the fact that this is sigma sub x bar. This is a subscript. So it just means a specific type of standard deviation. In fact, something I keep forgetting to show you. You don't have to do this. I got data in here. There's data in here. So if I ask it to calculate the standard deviation, if that's a sample, which thing is the standard deviation? What's the standard deviation if this is a sample? If this is a sample, what's the standard deviation?
9.16.
Okay, good. 9.12, blah, 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 right? If this is a population, what's the standard deviation?
8.16.
Yeah. In fact, do you see what the calculator says? Sigma sub x. So the calculator is even more freaking specific. It says, this isn't sigma sub x bar, this is sigma sub x. This is the standard deviation for individual data values. Now, we just don't write the freaking x, because we're like, if it doesn't have a little dude on it, we know it's a standard deviation for individuals. The calculator is very particular, which I kind of like. Okay, my God, so much. So now it's wide open to whatever you got left in you for questions. Is there any kind of problem that you still have trouble with? I want to remind you two things. What's the one question I'm going to ask you? Yeah, and I might change it to say, what would a z-score of 2.9 tell you? They're fundamentally the same answer, except if I said, what does a z-score of 2.9 tell you? That would tell you the data point is 2.9, standard deviations, away from the mean or above the mean. I love it. Second thing, I told you that I'm going to give you probabilities that do not add up to be 1. They add up to be 0.9999 or 1.0001 or something. You guys with me? Does that mean it's invalid?
No.
Why would that happen? Rounding. So how do you answer it then if they add up to be something like 0.9? You don't say it's good because they add up to be 0.999. That doesn't make any damn sense. It's good because they added in 0.999, which is approximately 1. That tells me you know they're supposed to add up to 1. Okay, not that big of a deal, but just, be careful. This one, I think they actually add up to be 1 if I remember correctly. But so any of these you want to focus on, let me do this. If you think you're going to have a decent number of questions, we could take like a little break. If you want to take a little break, or do you want to just go through it? What do you guys? How do you guys feel? Anybody really strongly want a break? Anybody really strongly want to just keep going? Okay. All right. Okay, we'll keep going. Any part of this practice test that gives you the most trouble? I'm sorry, Bella. Yeah, I lost you earlier.
What percentage within 1 standard deviation?
Oh, right here. Okay. So whatever we get for the mean, in fact, let's see. Do we want to do this problem real quick? I could do a quick example. So if you do this work and you get the mean to be 3, and you get the standard, which is not the right answer, and you get the standard deviation to be 1.9, let's just say, right? Within 1 standard deviation would mean put the 3 in the middle. Within 1 standard deviation means I go up 1 standard deviation and down 1 standard deviation. What is that going to be, smart boy? There you go. No. You're almost smart. There you go.
So it's just 1.9.
How many data points would I have caught if this was the right answer? Did I catch -1 between here? Nope. Did I catch 3? Did I catch 3?
Oh, yes.
Did I catch 6? No. Okay, so this is probably not the right answer. So then I caught all the 3s. So what percentage did I catch? 35.2%, right? If I caught all the 3s, if this was 6.9, I would have caught all the 3s and the 6s. What percentage did I catch? Add those. So whatever your answer is to part C, that tells you what to put in the middle, how far to go up and down, and then you see what data points did I catch, and add their percentages. If I caught all the 3s, I caught 35.2% of the data. Okay. So that's a good question. By the way, this test will be shorter than the first test. I'm going to give you 2 hours to do it, not 2.5. But we'll see. Yes.
Can we just go over one? Just 'cause-
The whole thing?
Yeah.
Okay, sure. Do I have a? I think I gave them all away. Shoot, and I got all this crap in the way. Get out of here. Get out of here. So how do I do number 1? And just in case, you really don't have to use the lists. You don't. You could just. What do I need this column here to be? XP of X. Yes, sir.
I was gonna ask, isn't it valid because it's the probability between 0 and 1? And
Yeah,
the sum
so-
equals 1?
Yes. Totally. Cool. Yeah, I'm kind of assuming we could all answer part A. What about part B? Oh, sure. Thank you.
Forgot to do it.
Yeah. If anybody notices weird things with the camera, like it's not turned on or something, just let me know. I don't think about it.
The cameras.
Yeah. I don't know if I told you guys the first time I ever did it, I actually put my water bottle like in front of it without thinking. So the whole thing was like a MC Escher thing where I was like, yeah. So let me know if that happens. Probably X is greater than 2.
Can you do like?
Yes. Yes. What's the only thing that leaves out? So I could do 1 minus this. Or you can add up all these. Why would I add up all these when 1 minus this will tell me what they add up to be? Right? Maybe? Yes.
So, if on the test, or I guess just in general, if when we're proving it's valid, we see it's like 1.001, but we know it's approximately 1, and we're looking for, if P of X adds to 1.001.
Oh, yeah, true.
Right, and is it okay if we still use 1 minus that because it's approximately?
Yeah, I'm fine with that because it's. But if you do use like 1.0001 minus that, that's even better.
Okay.
But I'm not going to take points off if somebody does 1 minus.
Okay.
It's weird when we round and it's not perfectly 1. Yeah.
So it's 1 minus 0.251.
Yes, because the only thing greater than 2 leaves out is -1. By the way, let me see if what is 0.251 plus all this shit? All this. What does that equal?
What?
1. So what's 1 minus 0.251? It equals all this shit. That's all we're doing. That's all we're doing when we do this. What does it leave out? 1 minus that. It's just a little quicker. Okay. Oh my God, I got so much crap written in here, but let me see if I can do this real quick. Let's do it in the calculator. You put in there x's and you put in there the p of x's. You make L3, I want it to be L1 times L2, so I get x times p of x. And you get a bunch of stuff, you blah, 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 blah. I'm not going to copy L down. And then L3 has got to be what? What do I want this one to be? X squared p of x. Now, real quick, if I square this list, do I get what I need here? If I square this list. If I square x p of x, do I get this? No, you get x squared p squared. Shit. I don't know if you guys understand. I know it's a very technical little thing, but I don't want x squared p squared. I don't want it. So, to me, the way I like to do this is to do L1 times L3. That gives me x squared p of x. So if I make L4, L1 times L3, I'll get my x squared p of x. Now here, let me show you. I don't know if I've shown you this. You could do the list sum business, right? What I do is I quit and I go to calc 1var stats, L3, L4. No, I don't. Why did I say that? I go to stat calc 2var stats, L3, L4. That's better. And then it tells me the sum of the x's, and it tells me the sum of the y's. It tells me the sum of L3 and the sum of L4. Now, just to remind you guys, if you don't want to do that, go to list, math, sum, L3. And you can also then go back up until at L4. And you get the same two numbers I got just a minute ago. I just needed to freaking add up those numbers. There's a few different ways to make it do that. So I get 4.253, that's the sum of x p of x. Oh shit, I'm putting it in the wrong place. 4.253, and the sum of x squared p of x is 36.139. Now what is 4.253? It's the mean. Kick ass. And how do I get the standard deviation now that I have no room to work with? It's the square root of this business minus the mean squared. So the square root of 36.139 minus 4.253 squared. So I got a mean of 4.253 and a standard deviation of 4.249. Meta. Just to remind you, this is what I was thinking of earlier. If you go to Stat Calc 1 var stats, tell it list 1 and list 2, because our data is list 1 and list 2. You can double check what you just got. The mean is 4.253 and the standard deviation is 4.249. See? You can check it. By the way, so what I really want you to get is, if you can't do part C, if you're like, ah, shit, I forgot, but you remember how to do this, then you can answer part D. Right? You'll lose points for part C, but you can answer part D if you just have the numbers. I'm not going to like that you made the calculator do this for you. You're going to lose points on part C. Part D, I can't do shit to you because you're doing the right work then. So what goes in the middle for part D? Yeah, 4.253. And then I go up and down 1 standard deviation. So this would be like 0.004. That's neat. And this will be 502 maybe? Woof. See if I did that right. Well, I've got the answer key, Jeff. Dujo. Pretty close. Why is it 3? It doesn't matter. Okay. So which data points? Did I catch -1 between those? No, because it's down there. Did I catch the 3s? Yes. Did I catch the 6s? Yes. Did I catch the 11s? No. Shit. So now I caught all the 3s and I caught all the 6s. So what percentage of the data did I catch? Add those together. 5, 4, 6, I think. By the way, if you're copying this down, I am going to give you the answer key, so it's got all this stuff on there already. It'll be just a little bit less busy. Now this sneaky suspicion that a lot of you guys haven't had a chance to even try the practice test because you might be focused more on homework and you're like, dude, homework's a lot. Yeah.
That's just saying you gotta write it money.
Yeah. It's almost like I've been doing this for a while. That I understand. I'm about to give you the answer key. Just to reiterate, do not just agree with me and think that you're studying, because I'm not going to give you, do you concur? Yes. I'm not going to give you that kind of a test. This is what I got. What do you think? I think you did it fine, Mr. Waller. No. All right, sorry. Let me see, what were these? Oh, these were the ones. Okay. Is that okay for the first one? I mean, in terms of which formulas to use, you can't beat this kind of problem. Holy shit. You use the formulas that have the x's and the p of x's in them. Right? It always troubles me when I see somebody answering this question using a binomial probability. What does this column tell you? What does this column here tell you?
The probability of X happening.
The probabilities. Yeah. So I'm just telling you, you don't have to calculate shit. You just give it to me. Yes.
Can you go over 4?
Okay. So that's number 1. Let's look at number 4. 4 is the one that's got the freaky stuff here. 4a, if I give you this problem, and I'm going to say this, I'm going to be really, really, really nice, because if you don't have the height on it, that's the most important thing. What would this look like if I drew it? Big old rectangle. Pretend like this is straight here. Poor little dude. And it would go from what to what? 2 to 8. And how tall would it be? Yeah, it's 6 wide, so it's got to be 1/6 tall, so that the area comes out to be 1. Because if I make the area 1, the area of any slice is equal to the probability of that slice happening. Exactly like the freaking little dartboard. Okay. So then a problem like part B is relatively easy, right? If I kind of draw this again, 2 to 8, 1/6, 4.4 to 4.7, right? It's not drawn to scale. I don't care. How wide is this? 0.3. So what's the area? 0.3 times 1/6. Right? So it almost doesn't matter the numbers I give you. It's just how wide, subtract those two, and then multiply by the height. Yes?
Wait, how did you get 6?
Oh, how wide is this? 6. And then to get the area, I'm going to multiply by the height. And I know I want the area to be 1, so this has got to be 1/6. Yeah.
The area always is 1.
Yeah, the area of the whole picture must be 1, because that represents all the probabilities added up. And that's why any slice, the area of it is equal to its probability of happening. Now, how many uniform probabilities actually occur in real life? Probably more than you think, but still not many. So that's why I'm not as concerned about it. It's just a nice introduction to areas meaning probability. Part C is nice, right? Is that 5/6? Do you multiply 5 times 1/6? No. What is the answer? 0 chance. Get out of here, 5. You ain't got a chance. And again, if the answer is the area, 5 has no width. So therefore it's got no area.
So it says equals, that means it's that's
Yeah, if I say, uniform, in any continuous thing, if I say it was probably equal something, 0 chance. And I talked a little bit about, it's not really 0, don't worry about it, it just says it's 0. For us humans, it's freaking, yeah, I am a human. So for us humans, it's 0. What's up? Zygote? Oh, iota. Zygote is that's pre-fetus, yeah. Let's not get into biology. I like that. No, I like that.
There was an ion.
Oh man, yes, that's true. Yeah, you got a correct vowel sound. No, I'm joking. This is weird. These are all weird words. What was the mean for? You guys remember? It's this. It kind of makes sense. If it's from 2 to 8, the mean should be right in the middle, right? And the standard deviation is this weird thing, 8 minus 2 squared divided by 12. 8 minus 2 is 6 squared is 36, divided by 12 is 3. It's the square root of 3, which I always want to sit down and memorize, but I never remember to do that. So square root of 3,
0.73.
yeah, 1.732, right? Now again, those are formulas. We talked about them a little bit. They're in the homework. They're just plug and chug kind of stuff. I'm not going to put them on the test. Why do I have another practice test? I'm going to tell you right in a minute, yeah? You good? Okay. We just calculated the mean and the standard deviation. This standard deviation works for what? Groups or individuals? Individuals, because I calculate it directly from the thing that was given. So if I pick one thing, this is how spread out they are. Part E, what's the very first thing I need to do?
Change the subdivision.
Also, what is the picture going to look like now? Where'd it go? What did it? 43. Is the sample big enough to do something?
Yes.
To do what? It's going to be normal. This is the theoretical in terms of this. Remember, it was uniform to begin with, this example we did, and then it became more normal. This is not normal. This is really close to normal. It's approximately normal because it started off so pretty. So if I start with a uniform and I take a sample size of greater than 30, I'm definitely going to get a normal curve. So whatever the hell that is. Well, this problem is a little bit more intense because you'll change the standard deviation, then you got to make z-scores out of these. You got to look them up. You got to subtract the areas. It's the whole problem. So here, let me give you the answer key. And again, if you haven't tried problems out, maybe don't even look at this.
Is it bad that I should look at these?
What's up?
Is it bad that I don't look at them and I probably should?
I don't know. It's up to you. Look for Robert in there. It's coming, Robert. All right, let's see. Yeah, so down here, here's the rest of this work. Change the standard deviation. Now it's a normal curve. You can make a z-score out of each of the data points, and then I could look it up. It's crazy. Let's see. I kind of want to show you this. You know, like, dude, you're the teacher. Do whatever the shit you want. Thank you. Remember this guy? Let me see if I could do this relatively quickly. Here we go. We got a mean of 7 and a standard deviation of 1.871, right? Right? If I wanted to know the probability, this might be a little too much, because you're not going to have to be able to do this. I could use this, since this is roughly normal, I could use z-scores to figure out probabilities instead of just adding them up. And you're like, well, why would that help me? Because I could this. If I had a binomial with n equal to 8,000, do you want to make that chart? No. So it's really nice. Later this semester, we'll talk about when do I know that an NPQ problem is normal enough to use z-scores to do stuff. So we'll talk about that in chapter 8. Yeah, chapter 8. But let me not do that. I was going to try to force that in there, but we just don't have enough time. There's nothing you need to know for the test, so.
Try to slip in the lesson.
Yeah, just trying to slip a little lesson in. You know, that's what us teachers do. Let's see. Anything else weird on this one? I think normally, if I were you, I think this would be a nice one to start with. If I were you, I would find where this problem is and just do it first, because it's the most kind of like recipe-ish thing. And then I might look for, I'm going to have a section like number 2 where I give you the z, so it's just can you use the chart, which is what this section is, right? And then I would look for this kind of problem. Do you see how I'm going to do this? You know I'm going to do this because it's a very teacher thing to do. I've got problems related to picking one, and then I pick 33 houses. I take a sample. So, of course, the very first thing you should do is change the standard deviation, right? Okay. Maybe. All right, there's a lot going on here. Of course there is. All right, that was a lot, guys. So any last little things, any of your brain cells not currently completely fried that can put together a question? Yes.
So, I know you said this like 1,000 times, but I'm still a little confused on, so I get when we change the standard deviation, the sample square event, and I hear what you're saying about ones for groups, ones for individuals. Can you maybe further clarify that? I'm just having trouble wrapping my head around.
So remember back in the days when we learned standard deviation the first time.
Yeah.
Okay, real quick. So let's say I have a population, a small population. So let's say, like I've got 1, 2, 3, 4. That's my population, right? And then I would do x minus x bar. Remember that?
Yeah.
And then we did x minus x bar. Oh, I'm sorry, mu. So just said it was population. U squared, right?
Right.
Okay. So that would tell me how spread out these individual data points are from their mean. Right?
Okay.
You with me so far? So that's this. That tells me, so when I do all this crap and I do the sum of x minus mean squared divided by n square root, that tells me how spread out each individual data point, how far they get from the mean on average.
Right. That chart tells you that. Right?
This would be if I do all that same work, but instead of listing the data points, I listed all the possible averages. So if I took, that's what I did on that sheet. If I took 2 at a time, I could get 1 and 1, that's an average of 1. I could get 1 and 2, that's an average of 1.5. I could get 1 and 3, that's an average. So if I just list all the possible averages of all the possible samples, and then do all the same damn work, that's what I would get.
Okay.
Thank the gods, because that's going to already be pretty damn long.
Yeah.
Thank the gods we don't have to actually do it. Based on what we get from this, whatever that number is, I just divide it by the square root of n, and that's exactly what I would get if I actually did all this frickin' work. I really want that to make sense. And that's why the kind of short way to kind of remember is the sigma we're given works for individuals. And I ask a question when I take a sample mean, I need to know how does that fit into the picture of all sample means. So real quick, let's see. If I had a mean of 80 and a standard deviation of 10, right? Let's say this is a quiz distribution. And I know it's normally distributed. Standard deviation of 10. So if I made a 90, if my grade was a 90, where am I in this picture?
One standard deviation.
Yeah, I'm 1 standard deviation up, right? That's me. I'm right there. Right? And maybe you make a 93 and you're like, beat your ass there, math boy. All right, shut up. So then you're a little up and somebody else is like, I don't want to talk about it. Right? They're down there. So this picture is made of individuals. Individuals make this picture. If I take a sample of 30, let's say 31. That doesn't matter. It's already normal. This picture is now made up of if I took a group of 31 and then plotted their average. It is definitely going to be skinnier. If I take a group of 31, their average should be closer to the actual average, right? If I pick one person and I get somebody who got a 38, that's like, oh man, but I'm not going to be freaked out. If I took 31 random students and the average is 80 and their average is 38, I'm like, whoa, holy shit, that should be really unlikely. If the actual average is 80, any group I take, I would expect it to be close. That's why the picture gets freaking skinny, because it's less likely for stuff to be out there. There should be less stuff out there. That's why this formula, You don't understand necessarily, I don't blame you, because I didn't show you, because it's beyond most of us, right? And that just means you haven't taken that much math. Sort of like, certain painting is beyond me, right? But the actual math, but at least it makes sense that as the sample size gets bigger, this thing should get even skinnier. If I took 100 students, holy shit, that average should be close to the actual average. It's really unlikely I just happened to pick 100 people that failed.
Okay, so the second one is you're taking all of their averages and then plotting it.
And that's what's in the picture.
And that's where you're.
So how spread out is that picture? This is how spread out individuals would be if I graphed them. This is how spread out every group would be if I graphed them. So of course it's going to be a smaller spread for a group because every group should be closer to the average. In fact, what if I took my sample was as big as the population? That's the ultimate. Then I would just have a line right at the mean. Anyway, that's a little too far.
So the second one's like an average of averages.
Totally.
Okay.
And I did have one semester, a student really didn't understand, if I took an average age in here right now, would that be different than taking 2 people at a time, averaging them, and then average all the averages? Would they be different? And I had a student that was just like, of course they would be. I'm like, did everybody suddenly get older? Did everybody suddenly get younger? What the hell? No, of course it's going to be the same average. It's the same people. Yes?
So it's opposed to taking one person as opposed to like on the worksheet 37.
Yes, so if I took one of you and I asked your age and then I plotted, asked your age plotted, and I make a picture,
But either way it's
that's the first one.
But either way it's gonna be the same.
The average will be the same. The standard deviation will definitely be small. So you guys are all individually a certain distance from the average age in here, right? I am pretty far away from the average age in here, correct? Okay. If I took groups of people, so throw me in with a group of people, now those groups are not going to get as far away from the average anymore because I'm averaging people. It should be really unlikely that the average, in fact, is it possible that I'll take a group of 3 people in here and the average is 50? No, because nobody else here is 50. Ooh, that's fine. You guys with me a little bit? Okay, so that's all that is when I am asked a question about a sample mean of a group, I need the spread of groups. I can't use the one they give me because that only works for individuals. Here's the funny thing. If I take one person, what's n?
1.
What do you get when you put a 1 in there?
1.
You get the same thing. That's what works for 1. The minute n is not 1, the minute n is some other sample size, that's going to change now. Okay, maybe. Okay. Yes.
Can you just go over 2A?
Let's see, 2A. All right, do I have any blank ones left? Yes. To the left, so this is that kind of problem that's really just, can you read the chart? That's it. So what's in the middle for a standard normal? If I made everything z-scores, what's the middle? 0. Because again, the z-score tells you how far from the mean it is. The mean will always be 0 away from itself. Where's negative 0.52? Get down here. And I want to know the area to the left of that. So notice that the chart tells me areas that are below a z-score I'd look up. That's exactly what this question wants. I'm just going to have to look it up and then I'm done. Right? So if I look up negative 0.52, by the way, real quick, below the mean is 50%. So if I go half a step down, we don't really, you could say maybe it's 30%, but it's going to be less than 50%. So when I look up negative 0.52, 3015. So it's interesting. If I take 1/2 of a step down, roughly 1/2 of a step down from the mean, I end up with 30% below me. Because every time I take further steps below the mean, I'm getting less and less and less stuff out here. And let me just use this word. We call this a tail. This is the tail. Kind of makes sense. Looks like a little tail, right? Even if it doesn't, We call it a freaking sample.
So, and then for B, you would like the right side of the chart.
Yeah, so now when I look up negative 3.16, it's still down here, right? 0, negative 3.16, but now I want this area. So when I look up in the chart, I'm not going to get the answer. So when do I have to adjust what I see in the chart is when the question doesn't ask for something below something. That's all the chart understands. So the chart's only ever going to give me the area below something. So if the question wants above, I'm like, shit. It's going to tell me what's down here, so I got to do 1 minus to get what's up there. Yeah. Come over. Let me tell you one thing, one reason why I don't want to move the test is because if I had moved the test, we would have talked about chapter 8 today. We would have reviewed 6 and 7, and we would have gotten chapter 8. Chapter 8 would be on the test, and I just didn't want to do that. So that's one reason why I decided not to move the test. Chapter 6 is a situation where you either you get it or you don't. It's exactly finding areas of rectangles, except instead of that, I have this. Every time I use this chart, it's just like finding the area of a rectangle. It's just, I need help. I can't do length times width, because it's not, look at that shape. What? Okay. Yes?
Do we have that chart that tests or not?
Hell yeah. Definitely bring this thing. If you have written notes on this, you will want to get a clean one from me. You will not be able to use something that has a bunch of notes written on it. Okay. Yes? Sure. I'll have some more on the day of the test if you need it. Okay. So right now, real quick, I can't remember how much I've told you about. If you're in the homework, let's say you're in the homework and you're in chapter 5. The test goes up through chapter 7. Okay, so that's a rough spot. You're in a rough spot. Stop doing every problem I assigned. Start doing maybe every other problem. Just freaking get practice with everything from those chapters, yes? Because the worst thing in the world is when a student turns their test in, they leave a bunch blank, and they're like, I just never got to do that for the homework. I'm like, oh my God. The most important thing is to practice. That's it. So if you can't do every single problem, I'm going to be like, finish this, That's nice, Mr. Waller, whatever the hell. I just do what I can. The most heaviest weighted thing in this class are tests. And I'm not saying that to make you all anxious about the test, but that's what your focus should be. Get ready for the test. And if you don't have time to do every single problem I assign, don't. Make it your own. That's what this is all about. Make the shit your own. That's what I did. Oh my God, my homework grades were not the best because I was working 3 jobs. I would, right? Little old man I am. I was walking up the hill both ways. But I'm like, I just did what I could to get ready for the test. I kicked ass on the test, and then the homework sucked. So my averages always came out to, who knows. You guys kind of with me? But, okay, so just don't hear what I just said to say, don't do the homework. That's not what I just said. Do enough from each section so you are ready for the test. If you can, do all of it. If you can't, do enough of it. Okay. Because I'll tell you this right now. I normally don't tell this until later in the semester, but I do not let homework fail somebody. You understand what I mean? So if I calculate your average without putting the homework score in and you get a 70, and then I put your homework score in, you get a 67, you passed. I don't let homework fail somebody. The reason I don't like saying that too early is because somebody hears that and goes, oh, the homework's not that important. Okay. And then you die on the test because you didn't get the practice. What I want you to get from that is, not doing every homework problem, that's not going to kill me. So I can just focus on doing enough, right? All right, I'm sorry. Anything else? That little spiel took a little while, I'm sorry. Okay. Again, I'll be in the classroom on Wednesday, I'll try to be here even a little earlier than normal on Wednesday if you want to come in with questions. And you got the Mass Study Center you can go to. Tomorrow, what's happening tomorrow on campus? It's closed, so don't come, right? Okay, so I'll see you guys Wednesday. Come on up here if you got any questions. Oh,
Have a good fourth, Professor.
you too. Thank you. Let's see. So, current average, where it could be in different situations, and this doesn't even take into account if there's quizzes you haven't corrected yet. So, it looks like you should be able to kind of, if you grade it, I think you already corrected the quizzes yet. Okay, so with those, they're late, but you should still get some points back if you get enough of them right. Okay. And then you can still make corrections and force it. Yes. Oh, thank you.
Can I have another practice test?
Maybe. I think I had some more blank ones. I think I gave them. Somebody already took like 2. Yeah, I don't think I have any blank ones left. It's up on Canvas though. Yeah. Sorry. Sure.
Are quiz questions on the next test or this test?
Oh, I told you guys since I gave you the quiz today, I'm going to give it back to you Wednesday morning, right before the test. But I'm not going to make the corrections due until the next day. Yeah. This guy? That's a good question. Can't remember. I don't think so. Yeah. We got to keep up with that. Let's see. Still there. Somebody's keys. Who else?
Oh, yeah.
Oh, okay.